Unit 18, Part 12, proving invalidity now. So let me remind you that you will not be asked to prove an argument invalid using the natural interpretation method, but you will be asked to prove in the exam, in exam 4, you will be asked to prove an argument invalid by using the model universe method. Okay? So that means, as I said, I think in Unit 18, Part 1, you can skip page 350 from, in the natural interpretation method, blah, 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 skip all of 350 from there and return studying on 351 from about here. From the model universe method is the same as before. The model universe method is also applied much as before. Okay, so remember back to Unit 16, which is where we used the model universe method to prove arguments in monadic predicate logic, invalid. It was the return of the semantic method. Semantic is in terms of truth conditions, right? It was the return of the use of the counterexample, right? The semantic method, the model universe method for proving an argument invalid seeks for and presents a counterexample to an argument to show that that argument is invalid. So recall, an argument is valid if it is the case that the truth of the premises necessitates the truth of the conclusion, right? If the truth of the conclusion follows with necessity from the truth of the premises. So an argument is invalid, right? So an argument is valid if it is not possible for the premises to be true and the conclusion to be false. So an argument is invalid if it is possible for the premises to be true and the conclusion to be false. And a counterexample is an interpretation, right? An interpretation of an argument whereby the premises are true and the conclusion false. So you remember, right, the truth table method in sentential logic. What was a counterexample? In the truth table, it was a row in the joint truth table of the premises and conclusion, which, right, a row, which means an assignment of truth values to the sentential variables, the P, the Q, and the R. Right, that was a testing argument forms. A counterexample was a row in the truth table where all the premises come out true and the conclusion comes out false, right? And so, and we were introduced to the short truth table method where we try to hone in on a counterexample. We don't use a truth table, usually in cases where there's too many variables, too many sentential variables, P, Q, R, S, T. Ooh, that's is it 32? 2, 4, 6, 2, 4, 8, 32, 16, 32. 32 row truth table, too many. So we try to make the premises true and the conclusion false, and produce a counterexample that way, right? Try to find an assignment of T's or F's, truth values, to the P, the Q, the R, the S equals, and present that as the counterexample. And I looked back at Unit 5 at an example of the short truth table method when I was teaching Unit 16, so you're reminded of what is going to be in play or was in play in the Unit 16 model universe method, which was precisely assigning, right, first of all, we're going to expand the formulas, or we did expand the formulas, we're going to do it again here, and then assign truth values to the atoms, which in this case are going to be things like FA, GAA, GAB, GBA, GBB. Right? Those are going to be the atomic formulas that are assigned true or false. And we're trying to find an assignment which makes the premises true and the conclusion false. Also recall from Unit 16 that the definition of validity changes a bit, moving from sentential logic to quantifier logic, right? In quantifier logic, what it means to say that an argument is valid is that it doesn't have any counterexamples in any domain, right? I quoted the definition from Unit 16, which has, or the definition of validity from Unit 16, which has two quantifiers in the English sentence, right? An argument in quantifier logic is valid when there are no counterexamples in any domain, right? So what that means is, right, so what is a domain? In the model universe method, we just treat, all we care about with regard to a domain is how many individuals there are in that domain, right? So what we do in the model universe method is specify a domain, and as before, I recommend starting with a domain of 2 individuals. So the domain, you say, this is my domain, set notation A, comma B, that's it. You give an interpretation of your formulas, reinterpreting the quantifier formulas to state what they mean in this domain. And the key to that, of course, is all universal statements. What does it mean to say that a propositional function is true of everything? Those translate into conjunctions, whereby, for a domain of 2 individuals, that propositional function is true of A, and that propositional function is true of B. And we have a conjunction. And of course, the existential formulas translate to disjunctions. What does it say to say that in this domain there exists at least some one thing such that this propositional function is true of it? It means, in a domain of 2 individuals, this propositional function is true of A, or it is true of B, right? And that's how we expanded our formulas, and that, right, the crucial move, as explained in Unit 16, was the move from quantify formulas to truth functional formulas, right? 2 formulas that were conjunctions or disjunctions, or perhaps conditionals if we had truth function, if we had something like a conditional where the antecedent and consequent were themselves quantify formulas. Then we'd expand those 2, leaving the conditional form in place. It would remain a conditional, but the 2 subformulas that are quantifier formulas would get translated. Okay, so we do the same thing here. It's just a little more complicated because you've got multiple quantifiers, including quantifiers embedded, in the middle of the formula, as it were. But the process is just, the procedure is just the same, as she says, I just quoted. What you have to do is expand the formulas in the way that you would arrive at the thought that this is the right thing to do if you thought about what these statements mean and what it would mean to translate them to a domain. What you do is you translate the leftmost quantifier first, okay? And then you get a truth functional formula, and you expand whatever quantifier formulas remain. Horizon.